Hello everyone and welcome to another episode of Nuwair Yudarris. This is your host Mahmoud Nuwair. Today we'll be speaking about equilibrium. We're going to be uncovering equilibrium, the equations associated with it, what kind of equilibrium um, phases or additions or removals would affect the total equilibrium of the equation or the reaction. So stay tuned. Don't forget to like, share, and subscribe. And shall we start? So equilibrium is the reaction that can go forward or backward. It basically can do a reverse reaction or a forward reaction. And equilibrium, what equilibrium basically means is that there is kind of roughly equal amount of both the products and the reactants. And then to calculate K equilibrium is basically products over reactants. And then the products have their coefficients. Let's say you have an oxygen here, for instance. So you have like, I don't know, 3O2. That's on the reactant side, so it goes down here and then the 3 goes here as the reactant for the concentration. Now, these equilibriums happen in aqueous solutions, so solids and pure liquids are not included. So they happen in aqueous solutions and under gaseous conditions. Okay, but if the reaction is gaseous, we use partial gas pressure for the concentration. If temperature change, then K equilibrium value will change. Temperature does have an effect on K equilibrium. The value of K equilibrium tells you which direction the reaction favors. So if K equilibrium is less than 1, it means that the reaction favors the reactants. There is more reactants than products. It means that they need to produce more or go more towards the forward reaction to produce more products, so it becomes equilibrium. Alright, what if KEQ is equal 1? The reaction has roughly the same amount of products plus reactants. And then what if KEQ is more than 1? That means that there are more products than reactants, and the products or the reaction needs to go in the reverse reaction to produce more reactants. But what if the reaction isn't actually at equilibrium? Then the expression is the reaction quotient. Alright, the reaction quotient is basically the same thing, the products over reactants, and it measures the reaction under non-equilibrium conditions. Now it's measured with the K equilibrium. So if the reaction quotient is less than K equilibrium, it means that it goes in the forward direction. Alright, so it needs to go towards the forward direction. But what if the Q, the reaction quotient, is actually more than the KQ, so it goes in the reverse direction. Alright, but what if KEQ what if KEQ is equal to Q, the reaction quotient? The reaction is at equilibrium. Alright, and don't forget it's the products divided by reactants. And here, for instance, they calculated this. I don't know if you can see, and the Q is 0.09. Alright, but the KAQ is 0.26, and there is actually more of the KAQ than the quotient, which is 0.09. So the reaction goes this way, forward. It goes forward, doesn't go in reverse. Next we have one of the most I would say personally one of the most important concepts they need to really pay attention to is Chatellier's principle. And it says that whenever there is change imposed on a system in equilibrium, the system will try to neutralize the change in order to re-establish equilibrium. So that is given here to us by this example. So nitrogen plus 3 hydrogen equals NH3 plus heat. So that's ammonia and plus heat. Okay, so let's say we add more of the product. Alright, so that's excess product. Alright, but in order to establish equilibrium, the reaction needs to shift to the left. Alright, it needs to shift towards the reactant. So that's where there is not enough KQ, alright, and it needs to shift to the left. and the reaction will proceed to reverse to increase KAQ. So Q can equal KAQ. So KAQ here is actually represents that it's not at equilibrium, that there is more non-equilibrium conditions. And then let's say we remove the NH3. All right, what if there is no product? So the reaction is supposed to go forward. It needs to go forward in the forward direction. And why is that? It needs to go to a forward direction in order to produce more products. So it shifts to the right in order to increase Q and have equilibrium. Let's say we add H2, so that's excess reactant. In order to establish equilibrium, and it's going to shift to the right. So again, it's going to shift forward. The reaction will proceed to increase Q. So if the reaction proceeds forward, it is to increase Q. But if there is maybe more of the product than the reactants, it's going to reverse. It's going to go to the reverse side, and there will be more of Q than KAQ. Let's say we remove N2, alright, no reactant. In order to establish equilibrium, it shifts to the left, just like I was saying. There is more of Q than KAQ. There is more non-equilibrium than KAQ, and the reaction will proceed in the reverse direction. Let's say there was a solid or a liquid that increased reactants or products, alright, but we already said that solids or liquids don't really count in the reaction rate or the KAQ or any of that. Alright, so they won't have an effect on equilibrium. Gaseous effects. So if volume was low on a reactant side and partial pressure was high, the reaction shifts to the right in order to reduce pressure and establish equilibrium. So basically, when the pressure is high, it favors the side with the less molecules. Alright, it doesn't really care if it's higher on one side and low on another side. It cares more about establishing equilibrium, and same goes vice versa. And then you need to pay attention to something, is that full octet gases like the noble gases like helium, for instance, it doesn't change neither the pressure nor the concentration. And then lowering the temperature favors exothermic reactions. Bonds are formed and it releases heat, and it shifts to the right in order to release products and heat. Raising the temperature favors endothermic reactions, because you need to add energy, you need to add the heat in order to absorb. You need to add heat so it absorbs it, and then it shifts to the left as it consumes extra heat in order to break bonds. And that was it for equilibrium. Thank you so much, and please let me know if you have any questions. And have a blessed day.